welcome. Welcome to Paratech's first webinar of 2024. This webinar is a virtual workshop.
Welcome to Paratech's first
It's
webinar
going to be a trench rescue, and it's conducted by Heavy Rescue Germany. That's basically in Germany. My name is Nigel Leatherby. I'm the training manager for Paratech. I'm just doing the intro and some of the questions in the background. Heavy Rescue Germany is owned and operated by Irakli West. Irakli has done extensive training over in the US with Michigan Urban Search and Rescue, with trench rescue, so he knows quite a bit. That's what this gives is a different perspective of how they do it in a different part of the world. Again, with this, there'll be questions, a question segment on the right-hand side of the page. You can ask questions. We can answer them to our best ability during the webinar. Again, my name is Nigel Leatherby. I'm the training manager for Paratech Incorporated. Now it's over to you, Irakli, to start your presentation. Thank you.
It's a pleasure and an honor to be asked to do this presentation about trench rescue and about our work. So I hope it's working technically. You should be able to see my presentation now. And basically, as Nigel said, it's perhaps a little bit different than what you might be used to. And this is our standard presentation we hold when we do trench rescue training. And let me just see if it's working. So just to kick things off, just to get to manage expectations, etc. And why this picture? So what you see here is what we're going to be talking about. And this is the first step of trench rescue is what you see in this picture. Hold back your questions because hopefully we'll have a proper explanation about this a bit later. But this is what we're going to be talking about. A little bit about myself, born in 1968 and I'm sort of active since 1985 as a volunteer firefighter in Germany outside Munich. And the main vocation is with a USAR team. We're an INSARAG classified light team. I've been to a few deployments. I'm a team leader. And apart from that, don't worry too much about the lingo. It's German. I am a consultant for one of our counties around here. We're setting up a system for trench or USAR, which I'll talk about a little bit later. Heavy Rescue Germany itself exists since 2009, and it started parallel to my work with Paratech, where I was employed 2009 to 2015. We just started with working in Germany with it's very empty, what's considering equipment. And so we set up this HRG, as we call it, or HRG in German, to offer training together with the rescue equipment. We've been on my own, independent since 2015. We are a distributor for Paratech for about half of the country, and we manufacture our own equipment. We also do training. It's 5 of us full-time in the company and about 30 trainers. Not all of them do all topics. Some are specialized in, let's say, new vehicles, electric vehicles and stuff. Some are USAR, and so we've got various disciplines. And also we offer some consultancy, especially what you see down here to the right is we write handbooks for special equipment. Just to give a little overview of who we are, what we do. We've been active around the world, including Chile, where we did some trench rescue training, but mostly we're active in Germany, all around the country. Since we are in Germany, just a couple of insights to understand why we do things as we do. It has to work with the system we have. And for example, here we'll see different types of fire trucks. And what we have in the middle is what we call a rescue, a heavy rescue with rescue equipment. And to the bottom left is a first due. It's like rescue engine would probably be the best translation. And to the bottom right is like pods, which have got special equipment. So for trench, for example, we'd have a first due fire department with a rescue engine. They can start working. Then we'll have more equipment come in as the call, as the work goes along, and giving us more options. We are highly standardized here. We have DIN, which is our norms, standards. Everything is standardized, and also the engines are standardized. So this 14555 would be the norm for our rescue engines and rescue trucks, I'm sorry. And here you'll see what they are supposed to do, why you have them, and one is for building collapse and accidents on construction sites, which would include technical trench rescue. So as an example of how this works, now without going into too much detail, we have a separation in Germany between local fire departments and the Federal Agency for Disaster Relief. They're federal, they're the blue guys basically. And sometimes there are two separate entities. So we would have the fire department starting the work, and then all the heavy stuff comes in from what we call the blue guys, or THW is the short for that organization. And what we'll see here is basically the system we have in the county of Dachau, which is close to Munich. We have first due fire departments that are trained in trench rescue. And we will have further along the line, we will get this pod, which has got all the timber, the shoring, more struts, measuring equipment, etc., which will be brought by THW. So to give you a little understanding of where we are, and we did write a book. So there's only one book in German, and it was written by us about trench rescue, where we sort of introduced what we call the rescue shoring to this country. And thanks to all the the information and all the courses we did in the States and the UK, and we translated that into German, not only the language but also the entire system, including all the sizes, the dimensions, etc., to have something that works in this country. The difficult task in trench rescue is to understand what we see in this picture. And first of all, we call them the group leaders, or the incident command, will have a clear idea of what they want to achieve, and basically they might have what we see here in the slide as a vision. And of course, the difficult part is to communicate what exactly you want and how we're going to go on about it. So that's why you need sort of a closed system, which the system in Dachau is geared to. Now, a little sort of sidestep and showing how we think. So the red, boxes, that's classical until recently. It started out of nowhere, and you would have fire departments would train what we call construction shoring. We'll look at it. And that's basically for working sites in intact soil, which is not really realistic because we get called to accidents. So far, the equipment was geared towards construction shoring, which again is not realistic. So what we did, we looked at actual accidents. We defined a standard accident, which helps us, like an SOP basically, which helps us define what kind of the tactics and equipment and training we need for that. Out of that, now this is more sort of for this topic here, how we would go about rescue shoring, and then we change the system with first due, etc. Also in the green box, you don't really have to worry about what's written in there, but it's regulations, health and safety, etc. So we are in touch and contact with them, and they're quite happy about what we're doing, and we are confident it will be endorsed officially in the not too far future. So this presentation here, it's a very long topic, and you could go on for hours and hours. So we want to sort of concentrate a little bit on the first due. Any accident that happens, the first responders will be either private persons, but we're talking about rescuers, which in our country will be a fire department with a rescue engine. And we'll look a little bit closer at what they can do to make sure this entire incident is managed the right way, and we get to make sure we get the right equipment with the guys trained guys with the right training, etc. At Heavy Rescue Germany, anything we do, we will split into 5 steps, which are a little bit of a sort of help to especially with topics like these, like trench rescue or USAR, which are not very everyday and not very common. So it would have it's kind of a little bit difficult to find the right word. The first step will be a 360 and to get an understanding of the situation. And this first phase ends with a communication with orders about what to do. Then we want to secure the site or the incident, which means we will freeze it in place and make sure it doesn't get worse for the patients and for ourselves, for the rescuers. In case of trench rescue, we would start shoring, and we would also start preparation of the rescue and actually perform a rescue. Something fire departments like to forget in training is actually about the patient. So let's look at real accidents, what they look like here. And here's an example from Berlin, where it's a very typical type of French rescue accident where a private person will dig out soil around a wall, a basement, to perhaps put a new liner in the basement or repair some bricks or whatever. And of course, private people don't know much about regulations and all that, and so they dig it the wrong way. There's not enough sloping, etc., and they get trapped. And what we see here is very typical for our country, where we would have some kind of struts put in and no real shoring panels, and also the clothes worn. This are their normal firefighting clothes, so they tend to be sort of heavy and they're nice and warm, but they're very bulky. So here's a couple of impressions. And what's typical of trench rescue is that it's a lack of space, basically. So at the top, you might have like a V-shaped trench where it sort of goes narrower towards the bottom, and at the bottom there's no room at all to work, and that's very typical, and that's not a German thing, that's a normal thing. So you must expect difficult working conditions. State of the art, or state of things, until recently, or still is actually, is what we see here, which is a trench rescue, is a partial collapse. And we'll see the type and quality of shoring that's been done is not too great. And one thing that's very important is when we do this kind of, we show examples of things that could be done better. It's never a criticism of people in the picture. It's a criticism of the system, which is responsible for making sure that rescuers are working in a safe environment. So basically what we see here is more sort of cosmetic type of shoring, and will not really take up any, won't really work, especially if the soil is active, and will put pressure on that shoring system. Same here. Another example is very sandy soil, partial collapse, and there is an entrapment. And basically here we're working with what would be standard on a rescue truck if you haven't geared or prepared for trench rescue. So it's just as a summary, they don't happen very often, trench accidents. They're very hazardous, very dangerous. It's very easy to underestimate the forces in soil, the weight, the forces. We tend to not be very well prepared for that, and but it's fundamentally a requirement for us because it is an entrapment, and as a fire department, fire service, we must get active. So, as discussed earlier, we did define a standard, and which always, no matter what we do, we'll always define a standard, whether it's heavy rescue, etc., because it makes it easier with a very concrete example to look at how that will be solved. And this slide we've seen before, this would be our standard accident. And how do we define it? What do we see? First of all, we have a partial collapse. So one side of the trench wall is collapsed. It's an entrapment. There's one patient. Is partially buried, so, and is conscious and communicative. You can talk to him. And why is that? It's very often a discussion of, how much time do we have to rescue a person, and just to avoid that type of discussion, because there are so many different types of accident that this is basically any technical rescue. The patient will define your rescue mode, and if patient is conscious and communicative, that means from a medical perspective is we do have a little bit of time, so we don't have to immediately jump down there and endanger ourselves. So we have a little bit of time to do some shoring. In terms of dimensions, it's 2.50 meters deep and 1.20 meters wide, as in this trench. The construction shoring until now is what we see here. That was actually part of the curriculum, so it's been taken straight out of some construction companies, how they would do it. And of course, it's not realistic because we arrive to a trench that's already there, that's collapsed, and we don't start from zero. And that's what it looks like if you want to build it. Construction shoring, which doesn't work just because we see it from the left. The left picture, there's a rotation, a collapse in here, and all these planks have been moved inwards, and there's no way that can be shored up properly. There's no backfill, no transfer forces. It's very extensive. There's a lot of stuff happening, a lot of equipment, and basically still not secure until the last struts are put in. So it's kind of not realistic. We're looking at what we call rescue shoring, which some of you or most of you might be familiar with. That, of course, gives us a lot more options. So in the left, a picture from the UK, which shows actually how this system works with a real trench collapse, which will never be parallel, but always very, very difficult to shore up. Here to the right, same thing in Switzerland, which was like a week after we went down to train them, and they actually did have a real trench rescue. And you see here with those containers, the concrete, the barrels, it's kind of impossible to make a straight shoring there. So, and it has been used in this country and is starting to be used. So we see here is an example from trench rescues a couple of years ago. Well, we do have a panel in here. We do have a pneumatic. We have a Paratech strut, and again, the size, the dimension, and so on of the hole kind of makes it impossible to make a proper shoring exactly like in training. You must be very aware of that, but it still needs to work. So why does it work? Why does rescue shoring work? First of all, you put two panels in there and a strut, and that's it. You've got an immediate and first kind of shoring in there to secure around the patient, and then you grow it. It can also be sloped to a certain degree, up to 20 degrees, we say. We can put backfills, and basically we want to transfer a conduit of forces from one side to the other. It works a lot better than construction shoring. Something else that's possible is deep trench. We do have maximum limits, depth, etc. We'll talk about a little bit later. But deep trench here is like up to 5 meters deep. 2 layers of trench panels, and you can see it's a large amount of trench panels. We have 6 on each side, so up to 12, just to have a secure working area in 5 meters depth. So of course it puts a lot of pressure, a lot of requirements and logistics. And down to complex shoring. This is probably the best, I'd say the most interesting trench we've ever done. That was with MUSAR. It was different levels of depth, different widths, and apart from that, the entire week was very cold and very muddy. And one thing that really impressed us was the rescue equipment, all the the struts, all the controllers, and all that. They worked that entire week without breaking down. So it was actually quite amazing. So yeah, the rescue struts, Paratech struts are central to that, with the possibility of putting air on them, so they're remote controlled basically, so you don't have to enter the trench to do your shoring. That's one main thing, of course, in terms of what they can take in load. Now, if you turn a trench by 90 degrees, you get building collapse. So this is a vertical shore, but technically it's the same thing, and you can see down here this piece of timber here. It's 20 centimeter piece of timber that's been compressed, and gives you an idea of how much pressure weight these struts can take. So where did it all start? Just a little personal type of journey, whatever you want to call it. It was a visit at FDIC 2008, where they do these hot trainings, and I kind of put the tick on the wrong box, and I think I was supposed to do some kind of CBFT, but ended up ending up in what we see here. Was the first impression we got of the struts and of shoring. And that was quite interesting because I haven't seen anything like this over here in Germany or in Europe, and completely baffled me. And so that's where it kind of started. Also, in terms of how much knowledge and training is necessary that goes into this. And also interesting to see the kind of materials used. We're way beyond that now. This shows how much has happened in the past 15 years now. But especially especially before Corona, the years before that at USAR, how much they took and experimented and took things forward. had the pleasure of doing a course in the UK at what was called the Fire Services College back then, the sort of National Fire School. And so the first sort of proper extensive training we did was 3-day training with the USAR guys. And here's an L trench, which is probably the most, I'd say, difficult type of thing to do in trench rescue. So all that was done from outside. And here again, we see sort of the old school, old-fashioned way of securing an L. We don't do this. The outer thrust block and stuff. It's done differently now. But anyway, that was pretty good. So yeah, we went to MUSAR a few years in a row, and also sort of saw the progress these guys were making with the testing and all the ideas they had behind it. That was really cool. So we took a lot of that back with us and translated that into our German system. Ended 2019, sadly, because of Corona, and we haven't been back yet. So hopefully at some point, I'm sure these guys have moved on, have done new. We kind of followed that and done new stuff, which really have to look at. But that's where we are. And I'm sorry, I forgot to translate the title of this slide. So what they do over there is they do load tests, when does stuff break? So like a point load on a trench panel at a correct spacing. You sort of measure the strength, how much it takes to break them, and out of that you can sort of deduct how well a system will hold with the expected soil forces. So we did the kind of tests with standardized equipment over here. And we had our in our team, we've got 2 engineers. They talked to the FEMA guys who did all the force calculations and stuff. So we came up with basically tables, distances and the equipment and recommendations which fit our system with our materials. And obviously around the world, materials are different. So it would have to be adapted to wherever you are. If you use a different type of timber, thicker fin forms or trench panels, etc. So our distances and our forces, they work for what we have over here. One very fundamental thing to understand is the potential of soil force that happens here. And basically, if you Google it, you will get a lot of things like these. And that's if you want to build like a new building and you need like 3 floors for a garage, beneath ground level, etc. You'll get a lot of these, but these will assume intact soil. And what we don't have in trench rescue is intact soil. Is soil in movement, is active soil. So basically, what we do must withstand the potential that happens. And the second thing is must be as simple as possible. So any normal firefighter whose everyday job is to, over here we do a lot of let's say we have to medical calls, or we have to open neighbor is not answering, and can you go and check, and then we go and check if the neighbor's still there and why they're not opening the door, etc. And but part of the mix is of course technical rescue, and especially like USAR stuff doesn't happen very often, so it's not in our minds. And so you've had 3 medical calls, and the 4th one is a trench rescue. It really has to be simple, with very little, very simple, let's say, way of working. So what we've done is we've translated all the potential soil forces, the breaking strength of equipment, etc. And we have a simple table. For example, basically you don't really need to know much more than if it's a normal trench, all shores must be placed at 125 centimeters apart, vertically and horizontally, and that's all you need to know. If you're in a doubt, if the trench is a little bit wider, then you might want to look up where you have to double the shore or decrease the distance between them, but it's still very simple. So that's all you have to remember. And why is that? We have a standard size in Europe. These panels are 2.5 meters, and basically we've got 60 centimeters from the lip and 60 centimeters from the bottom, which are maximum distances, and 125 between the struts. So for a normal panel, a standard panel, you should be able to work with 2 struts. There's also regulation. We won't go into too much depth, just to give you an idea. of health and safety and what would be, I suppose, OSHA in the States and HSE in UK, etc. There are basic distances and depths. From a certain depth, you must do some shoring, etc. But of course, if you get called to a trench rescue, it's because this didn't work. It wasn't followed. So therefore, it's not really applicable to what we do. And also, I won't go too much into depth. There are different classifications of soils. There is a DIN for that. And basically what we have to do, our shoring, is assuming the worst possible case, because there has been a collapse and we don't know when, where and how it will continue with its collapse. So therefore we have to assume the worst, and that's what we've done. Right, so why do trenches collapse? Why do we have collapse? And how do they happen? The factors, obviously, regulations have been followed and complied. The soil type, so you might have a very loose soil, and especially where you have two different soil layers in between, there might be less friction, so that's where they break and fall apart. Might be water coming in, groundwater. We might have especially what's called disturbed soil, so it's not the first time a trench has been dug right there. And of course the age. So the older, if it's a really old trench and you've just removed all the commercial shoring, then obviously it'll be a bit more it'd be less stable than if it was a freshly dug hole. So how are these collapses? What do they look like? We have a spoil pile, which is too close to the edge, and it might drop some of the spoil, which is in itself not a classic trench rescue, trench accident. But you have there are names for these, which you don't really have to know. It's just important when we do the regulator to have a look at it. So how exactly did it happen? So we have like a rotational type thing at full length, or a rotational thing collapse at half height, or we have a wall shear, it's called. The entire wall has broken and fallen down. And we have a little bit of stuff that's come out at the bottom. And these are actually the most critical ones, because we have a lot of overhang, a lot of weight, which is not supported. And that brings forces up to the top, and cracks and fissures and stuff might be starting to happen on ground level. Obviously, same can be on the other side, and from our research, usually the trench collapse will continue. The secondary collapse will happen opposite of the first one, not next to it, but opposite. It's not to say it's always like that, but it's most likely. And if you have like an L-shaped trench, then the inner corner, which is not supported on two sides, might be the more unstable part of it. Patient on his own, again, this is more of a technical presentation, is just to be aware of what could we expect from a medical perspective. So patient could be panicky or trauma, definitely, broken limbs, etc. Suffocating, which in which case becomes more time critical. So-called suspension trauma, which means all your so I hope the translation is sort of all right, but you have basically, if you don't move your limbs and they're cut off, and all the let's say bad stuff, the blood cools down, etc., collects in your extremities, hypothermy, yes, and so-called recovery death, which is closely related to suspension trauma. Your patient is hypothermic, all the blood in the extremities is cold, and you bring the patient up, you put him horizontal, and the system starts to work again, the circulation works, and basically that's when they pass away, just because of this bad blood. In a very simplistic term, will be an issue. We like to be structured, so we will have to think right away of how to structure the entire site when we arrive there. First use, so you have 3 zones, and basically, first of all, the zone itself, the danger zone, or the actual accident happens, where you just want people, rescuers who actually have a job to be there, and equipment that's needed, nothing else. Then you would have a wider cordon, which is yellow here. It's called logistics and cutting. Well, readiness, or whatever you want to call any other units that might be called upon but not needed right away. They park a little bit further away. Don't worry about the German names, it's just the graphics, just to make it more clear. What we have here is the trench. In this case, I think we see a building, but it's the same thing. And it's if we can coordinate off, it's always a good thing with a single point of entry. in trench rescue, not always easy. And you would have the equipment, and you would have the cutting station. It's very likely you'll have to do simple cutting work like shortening timber or making the trench panels narrow, etc. And otherwise, keep in mind, keep a free space for a crane or a turntable ladder to be able to do a elevated fixed point or a vacuum truck. So let's get back to our 5 steps of rescue. Where we're looking at equipment, this is usually what we would have on a first due engine that's equipped with rescue struts, airbags, a sawzall, a drill, etc., and our little panels in a very small format. They have the same thickness as the big ones, but they're obviously more compact to be able to be carried in the truck, and an assortment of rescue struts. The trench panels themselves, they look like this. They have certain material, and we did mention there's a standard size, but you can also make mini ones to fit your truck. The logic being that it's better to have some than none at all. And even if they're smaller, they're still very useful and will work in a trench rescue. Where they work pretty well is if you have a lot of say curves, and they kind of like to be more flush than the big panels in a trench. So here we are, our 5 steps, and let's start with our understanding of the situation when we get there. What do we see? All the things that interest us. First of all, what day? Is it day or day night? Is it a working day, or if it's in the weekend, it's probably more likely it's a private person. What time of the day? And when you arrive, the placement of the spoil pile. The spoil pile is what we see in the back. That's the stuff that was in the trench that's been dug out. In an urban environment, it won't be there. It'll be taken away. But like here, it's been put too close to the trench itself, which tells us it's probably a bit unprofessional. But also the size of it and the consistency and how it looks. If it's been there for days, then you can see, and it's been raining, you can see it's an old trench, which makes it more critical. And it cracks on the surface when we get there, so be careful about going to the edge of the trench. And how many persons are involved? That's not the patient, but outside, do we have any colleagues or family or whatever? And what was done down there, we can find out by asking where it was gas mains or electricity or what's happening. And obviously, how many patients are down there? It can be more than one, and where exactly are they? If the collapse has happened on an entire length, of course, it might be more difficult to locate them. If you look from above, the trench itself, a straight trench, will be this gray surface. So you try and approach it from the corners, which are the most stable part. And the short ends would be less stable, and try and keep away until we've secured the trench from the long sides. For a T-shaped trench, it's the same thing. You would like to keep a safety zone, we say about 60 centimeters, where we don't step or do anything until we've secured it. Get as close as possible to the trench and see if you can look inside. If you can, this is a good time to start measuring it, because we do need to know how wide especially it is to be able to put our struts together. Look at the soil itself. What type is it? Are there any layers of soil? Where did the collapse happen? And what type of collapse is it? And where can you see any further developments? Where else would it collapse? And are any obvious hazards such as water coming in and etc. So in the end, after you've looked at all these things, you've taken all that into account, you set up a plan. And basically the plan in this case looks something like this, and you want to say, so what are we going to do? First of all, how much time? This is we always work together with emergency doctors. We will have ideally we'll be able to provide them with an exact time. It will take 60 minutes, or let's say 40 minutes. You can down the patient. And any other thing, trench panels, do we work with bridges? Any hazards down there? Is any problem, etc. Let's look at the bridges. First of all, a lip bridge is this. This obviously is our trench, and the green bits is the actual bridge. And what does it do? It transfers a load as far away from the edge of the trench as possible. This is a practice trench. There's 2 of them in Germany, which we've had the pleasure to design. and these fire departments have built them. So it gives us the opportunity to train how to work the equipment, procedures before we actually go out in the field and work in a real trench. So what you see here is the lip bridge. This guy here standing on it, and his weight is being carried away through these, I think it's called abutments, but I'm not sure that's the right word for that. In any case, and the transfer of the load is happening here, which is away from the lip. For our rescue engine, there's a possibility to do the same thing with ladders. Now this is a bit of a demonstration. It's too short and too close to the edge of the trench, but if the trench was much narrower, that'd be all right. Or we can double the amount of ladders. We will very likely in this country have 2 rescue engines on site right away, and which means we have 8 ladders, so we can double all these ladders. And just the bridge, to be able to run it, we put a plank or something. And as it's a constructed site, it's very likely we should be able to find a tough plank or something like that. So now we get to work, and how do we go about it? The first thing we want to do is put out ground pads, and that's basically just any kind of, in this case, it can be, on the truck. Ladders will work as well. You can even use spine boards. You can use whatever. It's just to spread the weight. And one thing you don't need to do is to put them, like we see here, everywhere around the trench before you even start working. It's sufficient or enough. You want to be as quick as possible to set the ground pads right where you will do your shoring, or you will build a lip bridge, etc. Second thing that goes in is a ladder, which is an escape route, which is an egress in case one of us, a rescuer, falls down. That's a way to get out as soon as possible. Ladder goes in first and comes out last. If possible, if you have any hollows or hollowing, or whatever you want to call them, voids, underneath your ground pads, you might want to mark them with a spray. Pretty soon you would also want to, because it's confined space, technically you want to monitor the atmosphere, and we usually put 2 of them down, one at half height and one at the bottom of the trench, and we will always ventilate if possible. Now, regardless of what the measurement is, just make sure we do have some fresh air down there. What doesn't work is to put a heater with this kind of hot air. It just makes the air unbearable down there and does not warm up the patient at all. And obviously, if there's water down there, you want, now we call the water management, just throw a pump in there and make sure the water level is kept as low as possible. So that will be securing, no more than that. And now we start working on the rescue shoring. I'm sorry, the securing might include putting up a lip bridge as well. So rescue shoring, if you want an initial or rapid or initial shoring, just to get something down there, we put 2 of the panels down, and we put 1 strut, preferably at half height. Now, if you have full-size panels, it'd be at half height. But now it's all options. We don't have to do that. If situation allows, we can put the first strut already at the right position, a bit lower. But in this case here, that's what we want to do: 2 panels and 1 strut, and that's it. So we're talking about 10 minutes after arrival, which is our goal, to have this kind of setup to prevent more stuff falling down on the patient and endangering him even further. Just to be clear, it's not a safe working space. It's not considered safe for us to go down. It's just a quick way of making sure the patient is safe. So that's what it looks like in an exercise we did. Here you can see the ground pad is on a ground pad. It's a ladder that works just well. And now, because the panels didn't have any ropes on them, these guys had to hang down and lower them by hand. And we just put 1 strut in, we shot it, and that's it initially. So now the patient at the height of his head is kind of safe, and we can continue. And to continue, looks like this. Basically, we built a bridge, again, a lip bridge. And you can see here the girders, or what do we call them? There's 2 ladders, again, with a plank on top. And we start putting panels in there. There's already the initial strut, you can see. And those would be the distances we would want to aim for. It's not always possible, especially since the bottom of the trench isn't always straight, or the lip is not always an exact 90 degree. It can be a little bit sloped. but you want to be no more than 60 centimeters from the top and no more than 60 centimeters from the bottom, and your maximum distance between the struts would be 1.20 meters. If it's more than that, excuse me, you would have to add a third strut. So it's kind of a growing system. So we'll see here where the pointer is, that's the initial small panels we set, and basically the entire system started working around it. The next panel, set of panels, next set of panels. At some point, we say technically it's safe to go down if we have a pair of panels that are secured by two struts at the right distance. Then it's safe to go down. In practice, it won't be enough room because you still have a patient down there, the ladders to go down there. So ideally, we want to see two pairs of panels before we can even think of going down there. In case there are voids, you need to make sure we have load transfer, so they would have to be backfilled. And for this, it's pretty much the only case where low pressure bags still make total sense. Just because they are large and they make sure the void is kind of filled really well. It's a little bit more equipment to work with, but it makes it safe and works really well. If we are sloped at more than 20 degrees, then we would have to set the panel straight and make sure we have some sort of shoring. So we call it outside shoring. Here's a panel that's standing straight, and obviously we can't backfill this. It's too much of a slope. So we simply use, basically it's a lying down double T, if you're familiar with shoring. That's what it is. It makes sure the panel doesn't twist. Just one strut behind is not that good because you would have torsion in the panel, and here we can avoid that. Here's a smaller version. Here we've sort of cut a panel in half, and the shoring basically is the load transfer is happening here. That's when the void is too big for rescue bags, for low pressure bags. When we enter the trench, you want to make sure you fix the struts. You can use nails or screws. They're different, let's say, schools or beliefs. We use screws. It's just less vibration. When you go down, always start with the top ones, and you work your way down. And you need those, of course, because as we said, it's active soil. We do apply some pressure, which will ideally be around 500 or 600 kilos per strut, and which translates to 16 bar for the Paratech struts. And basically, if you apply that kind of force, it might compress the soil and loosen other struts that are already in there. And obviously, if they are not fixed in place, they would fall further down. So that's why you want to secure it. And you can always, if you find it's become loose, you might have to fix them further. And a good tool for that is what this guy is holding, is the Paratech shoring hammer. It's a really good tool for that. And it's actually made to tighten the collar of our Paratech struts. So I was in essence, that was sort of the main points I wanted to talk about. Three initial points, the understanding the situation, then we have securing the trench, and then shoring. And we'll just have a quick overview of a couple of slides on how we continue from there. Then we want to prepare the rescue, we put the shoring, and the patient is of course still trapped, so we might have to consider what type of tools. And you really want to work in a very confined space. So here's an example from the UK. Instead of a hand drill, what we can use is let's say a drill with batteries. Work really well, but as long as you have some very big drill that can loosen the soil. But otherwise, it's all very entrenching tool. All these tools that don't take a lot of space. And the actual rescue, of course, just keep in mind there's not a lot of space down there. So it's not a lot of equipment that will work properly, and it has to be very compact. So what we have here is like a sked. There are several more modern versions of a sked, but that type of rescue equipment works quite well down there, just because it doesn't take up that much space. A normal litter would not work at all down there. And also to keep in mind, you can't use the struts as a ladder rung or something. You can't step on them. That's a no-go. So in the end, as a rescue, just make sure you set up in parallel when your rescuers go down and start digging and freeing the patient. At the same time, you would already have a plan of how to rescue the patient. You could use a turntable ladder, a crane, or if you're out in the field and there's not a lot of access and so on, like here, we could use the Paratech bipod. It's a good tool for that. Much better than a tripod. Tripod would have to be right over the trench, and that's will usually be very difficult to achieve. Where we recommend the bipod. So that's it from me. You get a German Danke, which is thank you very much, and hope that was okay and understandable. And my understanding is there'll be a Q&A after this.
Thank you, Irakli. That was a great webinar. I hope the rescuers out there got something from it. I know I did. To the guys out in the world, we are going to stay on for the next 10 to 15 minutes, Irakli and myself, for any questions you've had or any questions you put in the chat that we didn't answer during, will be answered in the next 10 to 15 minutes.
That's an open microphone. I don't know if it's working.
Yep, should be good.
Can you hear me?
Yep.
Okay, so I think there were two questions, all right, and one we've answered in the chat. The other one is Tom. The definition of a safe trench.
Yeah. I'm going to read off the first question, Irakli, so if you want to ask the first question. This one's from Daniel Bush. Does your program show the interior of the basement when pressurizing strut against the foundation?
I think there's a bit of an audio feedback here. The question with the basement, we would look at the consistency, the type of building. If it's brick, you might have to have a closer look at drawing of the basement.
Is there another question, Nigel?
Okay, Irakli, the second question would be from Damien Cameron. Yes, appreciate that. Actually, it's from Tom. It's from Tom Defina. I've been told, but I believe I won't find anything written in the books. If a trench is 8 feet or less with a viable patient, is one strut okay to get rescuer in to start working and extricating?
Okay, I'll have to make it a quick answer with the audio feedback. No, by definition, we have two struts set at the right distance to make it a safe working place. In reality, though, you have to make an assessment. There's no way to put that. Hope that answers the question.
Next question, Nigel.
That's it. That's the 2 questions we had.
Okay.
We do have one more question from Damien regarding I think what sounds like the L trench, and it's correct. We don't do that anymore.
Yeah, we don't use thrust blocks anymore. We use cantilevers. Let me look. Okay, there's another question from Michael Kuhn. Would the most secure way to uninstall the shoring be the exact order in reverse?
Yeah, I'll answer that. We'll try to get the entire system out in one go. We would release the struts and attach the whole storage system to a bucket or crane or something to lift the system out. Although you would take it out in reverse.
Okay, was there any more questions?
No. Okay, I think that's it for the questions. Well, again, Irakli, thank you to yourself and Heavy Rescue Germany for putting on this presentation. My name is Nigel Leatherby. I'm a training manager for Paratech Incorporated. Don't forget to subscribe. When you subscribe, then you keep in touch for our next webinar in the near future. Again, thank you again. Bye.